Hey everybody, how's it going? A long time no see. It's been quite a bit of time since I posted to this channel. You know, just the good old-fashioned stuff going on, life and whatnot. But yeah, I wanted to make another sort of loose, just programming video. Sort of the same style as the last video I made in here. Just me doing some Jai programming, good old-fashioned Jai programming. Yeah, and the context for today's video, or just for this little session, so I have a base library, right? And this just has a bunch of stuff that I like using and that I have been pulling around between projects. And one of the things I know I'll need eventually, and I'd rather have that now than later, is just some stupid basic JSON functionality. So I started writing that and I said, hey, why not make this into a video? I'm gonna sit here for like an hour, 2 hours. Might as well make something fun. So that is this. Yeah, so we've gotten to this point so far, which is just sort of the scaffolding. So we have a JSON value, and we're doing this in a, a not horrible way, where we're going to be, storing pointers to like a base JSON value and all that stuff. We're just going to have a big fat JSON value struct that is just an enum and a union of the different types. So we could have an array, which is just going to be this main struct type. We can have an object. We're going to separate the keys and values so that we don't have to do like a hash map style, a hash map styled object, just because I'm still needing to write my own hash map implementation in Jai, and I'd rather use that than sort of piggybacking off of the hash table implementation currently there. We got booleans, we got numbers, we got strings. That's really about everything that can be in a JSON object. Now before you're saying, oh, where's the RFC? Aren't you gonna make sure it's a complete spec compliant JSON parser? I'm not doing that. I'm making it parse the JSON I tend to use, which is like literally everything in the spec, plus, trailing commas, because not having trailing commas when you're handwriting JSON is very frustrating. So yeah, that's all we're going to be doing. We got the little basic setup. So the first thing I'm working on is just the unmarshalling, which is just going from a string into some value. So there's going to be an interface sort of like this. This is the base interface, where we just want to parse into a JSON value object, and that thing is going to contain a bunch of other ones. And then we'll have this actual fun one, which parses into a type. It parses the JSON into a type, and that's just going to piggyback off of this one, right? Because once we have a value, all we really have to do is just, shove the data onto a new type. We're kind of good to go. So the way we do that is we're just going to create a parser, right? Parsing is what we need to do, and it's not hard. And this is what our parser looks like. So we need some sort of pointer to our data that we're giving it, this data string. We need an offset to know when we're at the end, and then we need an allocator because we're going to be allocating a bunch of these JSON value structures. And we actually need... So there's a couple ways we can go about this. Because these aren't pointers, when we make them, it's going to be a bit weird. And I guess not really, because if it's an array, we can just push directly onto this array, the object we parse, and then if it's an object, we just write the keys and the values. So we'll mess around and we'll see where we get. But yeah, so we got this parser set up, and we just need a little parse value function, procedure. I never know whether or not which side to be on with the whole, is it a procedure? Is it a function? I know a lot of people have some opinions on that. I tend to not really care generally. But it's just semantics. So let's at least do a little bit of nice stuff here. Yeah, cool. So the first thing we need to do is we just need our main sort of loop. And I'm actually not sure how I want to do this. I kind of want to do on-demand parsing, which would be this thing we'll call parse value. And because all JSON objects, JSON files start with an object at the front, or at the, the outward level, it will parse the value, right? This object, which will then do the rest of the file. thing I kind of want to allow is like fragment parsing. So if I just go like, hey, JSON unmarshal, you know, hello, you know, something like this, hello world. Oops. Yeah, that should be fine. Right. I kind of want to do this where somebody can give me a string like this, and then it'll just return a JSON, what is it? A JSON object with one key, one value. Same thing, like if you JSON unmarshal a like Boolean like false, right? That is a JSON value. And that'll just return a JSON value with the Boolean set to false. So I kind of want to do that, or make that a thing. And the easiest way to do that is, first we just need to check if the offset is greater than or equal to p.data.count. And this is going to be signed, so we need to check that to a uint, and then we can just return an empty object, because an empty object just means none. If we didn't get anything, we just want to return none. I kind of want to keep the error handling a little nicer. I don't want to be doing this all over the place, right? Because then my actual parsing code, whenever I need to say like value okay, right, parse value of p, and then I need to go if not okay, return empty string false. And so I'm like bubbling up errors all over the place. So I'd rather just return a value as is, and then in the parser itself, that'll hold on to an error like so. And that error will just be the latest error that it had. And you can see us looking at that right here. You know, we'll check a little to do. Judah is my name after all. Logging. Let's see. Nice. And I'm working on a new setup. So things are going to be a little bit rough. Let me even see. Can I just... Okay, so I do have jump to definition, so things aren't too rough now that I'm thinking about it. Yeah, okay, cool. So now we just need to do the first character. So data dot boom p dot offset, right? Because now we know we are in range, and we need to do a nice little if starts. Yeah, we'll do starts object. I guess there's only really one thing that could start an object. That's one of these bad boys. And if you are noticing, we're going to forget one thing right now, but we'll come back to it later, and that's going to be white space, right? Because in this string, there's going to be white space characters leading up to this, and we want to make sure we skip all of those before we look for a character. And I guess, why not? We'll do that right now. So we'll just do a little skip white space of p, skip white space p parser. Boom, and this will actually return a Boolean. So that way we can do or not skip white space, like so. And ooh, we can make this even better. So we'll do a skip white space at the top, and then we'll do our one check of end of file. Oh yeah, now we're doing something. So that doesn't even need to return a value anymore. So now we can do a little while p offset less than p.data.count. Cast that shit to uint. Sorry, this is a family show. My mistake. Yeah, we can just do a little p.data, p.offset. The classic. If you've written a parser in Jai, you have done this many a time. So we can say if C is one of these, a little space character, it's a tab character. I think we can support vertical tabs. We can also support \n and \r. We just want to do a little p.offset plus equals 1, and then a little continue. Actually, we'll make it a little easier to read. Otherwise, we'll just break. And then, of course, we got to check a couple of throughs on here. Align them because not log out. Got to align them because we like aligned code. And that is a skip white space function if I've ever seen it. We should probably also report line number and character number. I think for now we'll just do line number. Like so. We'll just call that line. So that way error reporting, there's at least some some easy way to find errors. We only want to do that when we get to a \n. So we can do this, p.offset plus equals 1, p.line plus equals 1. And there we go. Right, so we're just doing a good old thing. Actually, can I just do one of these bad boys? Can I do that? I never do stuff like this because I kind of hate how it looks aesthetically. And it kind of breaks my brain thinking about what it actually does, right? Like, I know if we see a \r, we're going to go p.offset plus equals 1, right? We're going to increment that, and then we're going to hit this through. Is that through going to then check this condition and then fall through to this, right? Or does it just jump to the block? I would assume that it checks this, right? So I would have to do like c equals p.data p.offset, which means I could go over the buffer, repass the buffer. So it's just a lot simpler to duplicate the code like that and not care about it. So we got a little skip white space, and I think now we can just do one of these, right? So we can just go into here, case char, boom, case char. What was it? \4 strings, char. What else do we got? We got an array, which would be one of these bad boys. We have t, that'll be our true and our false. And we have a n, which would be our null, and then anything else would be a number. Now, one thing we should do, and this is actually what we will do, right? Because these are all letters. We can actually do just like a is identifier, and then when we see an identifier, we can either mark it as when we know, which is true, false, or null, or that then we have an error case, right? Which if we go here, then it kind of affects our number code when we parse it in. So we're going to do that. So what we're going to do is we're going to say capture while, and this will be a value. And actually, we need to do one thing. So we need to check in here if c is greater than, whoops, I cannot write code right now. So if it is greater than 0 and c less than equal to 9, right, this would start our number. Or if c is a dot, because I'm not sure if this is in the JSON spec, but you might write this, right? And we want this to work, right? Because it's easy to write. We don't want to force this. I don't care if it's in the spec. That's just, it's very easy to support, and it makes our parser nice to write. So this will be a number, and then this will be a true, false, null, right? Once we get here, right? Because we're not an object. We're not a, what is it? An array. We're not a string. So we're either a number or an identifier. And yeah, that's really about it. So all we have to do at this point is just write a couple of little utilities that we usually need when we're writing a parser, similar to skip white space. I'm going to do a nice little capture while. And all this is going to do is take our good old-fashioned parser. I don't know why it's been a little bit since I've recorded, so I'm kind of talking like this is a tutorial. Like you're supposed to follow along at home and write this code. So maybe I should shut up. Maybe that's the actual thing. Let's try that for a second and see how that goes. I don't like that much, so it's not that fun. So yeah, capture while. It's going to be used like this. So we know we're in a number context. So we can do number is capture while our parser. Because Jai has lambdas, we can do C or like N, and then we can say while. It's just going to be this exact same. What is it? It's going to be this exact same thing, like so. Right, so we can either do that. Usually, what I do when I write parsers for like compilers and things like that is I will do something like this. So I'll do a starts identifier, or I'll do starts number. That's going to take this, returns a little Boolean. And then we just return that same expression, right? Because we're saying, hey, we either want a number to start with this, or this, or this, right? So it's either a number or a period. And then when we go, we write another one called continues number, right? Because the rules are going to be a little different, right? If you have like number separators, you kind of want to do this sort of process. So we do either return starts number, or see, you know, maybe we allow underscores, right, in our numbers. Yeah, maybe we allow underscores in our numbers. And so, you know, that is a thing we could allow. But we don't want a number to start with an underscore, right? We only want it to start with these. But, yeah, so it's just a helpful way to do this, right? Because then you can expand on the code. And then when you have your capture while function, right? So this would be a little if starts number like this. And then you do, yeah, your number is a capture while p continues number like so. And then you're good, right? Then you have like a nice little interface for this and you know what you're actually doing. But we're not going to go that far with it, right? I don't care that I'm duplicating this expression, right? This conditional expression. It's kind of whatever. The other thing we could do is just make this a macro in here, so that way we don't have a function. Blah, 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 blah. You get the gist. So we're just going to do if number.count not equal to or 0. Return an object where the kind, a struct, right? We're not in JavaScript land. These are structs, like our forefathers used to use. We're going to make that a number. Why are you complaining now? Nope, a little semicolon. Or are you complaining? We press declaration. Do I need to return? I forget. No? Oh, probably that. Yep. Cool. I don't remember if Jai can do this. No, it does not. So we need to do that. Right, just return an empty. Yeah, so we just want to return a number, but we want the value to be nothing because we didn't actually get anything from this capture while, right? Maybe it was just a single number. I guess that is not a case we'll ever hit. So let's just add a little assert of number. Basic.assert number.count not equal to 0. Huh? No, we'll delete that. And let's make sure we're importing basic. And I'm going to namespace all these imports like this, all the ones from the actual standard library, because I'm going to be replacing them in the future, so might as well make it a lot easier on myself. Cool. So, capture while. We could do a little skip white space at the start of a capture while. We don't want to do that. Yeah, we don't want to do that because we're writing this code. We know a capture while or a skip white space is always going to come before a capture while. And we know we're always going to start in a capture while after one of these characters. So we can just use that assumption initially and not bounds check. If we want to make our lives a little less insane, we can just do a p.count, p.offset less than p.data.count. Just to make sure we're not going past the buffer unexpectedly. Once we start getting recursive and whatnot. So there is one thing we need to do, and that is if we're capture whiling, we're going to say our capture is just an array of U8s, and that is going to be our p dot offset, or sorry, our p dot data capture dot data plus equals p dot offset. This needs to be like that, and then capture dot count is 0, right? Now it could be 1 because by the time we get a capture while, we already know we've hit a character that we care about. But I'm just going to keep it 0 as a sort of sanity check. But all this is doing is we're making a slice, like a Go style slice of this data array, this data view, and we're just saying, hey, start at the current offset, we're just going to count up while this proc succeeds. So now we just do a little bit of this. P.offset less than P.data.count. You int. You might be seeing a lot of repeated code here, so let's chuck that out and do a not end of file. Not end of data. Not end of data? Not end. Not end. I like a good not end. So we'll do end. Parser returns a little quick boolean. And then we'll just say more than equal. I like actually at end. Boom. Now, let's just go into here. Not at end, P. And now we're getting rid of all this because we're going to rewrite that a shit ton. A lot. A lot ton. Cool. So not at ends. Boom. At end. Inline. Why not? Okay. So while we're not at the end, what we're going to say is if proc C is P.data, P.offset. If proc, if not proc, break, because we don't want to do anything. Otherwise, capture.count plus equals 1. Now, there is a way we could do this. Actually, let's do it the fun way, now that I'm thinking about it. So what we're going to do is we're going to do a little if proc, if not proc, of C, we break, like I said. Otherwise, we're doing P.offset plus equals 1. And then down here, we no longer need to make our capture at the top. What you can do instead, our count is capture.data. So that'd be actually P.data.data minus P. P.offset. And this will be an integer. Uint? No, essence. I'll be saying, what are we doing here? So we're incrementing offset, which means that when we started our data here, and there's already a bug in this, but that's fine, right? We just need to do this. We need to do this here, right? Yeah. So we're going to hold on to where we currently are in the buffer. We're saying, hey, capture data. And then we're just going to say capture count is 0, just in case I try to print this. I don't want it to crash on me. Right, and then we're just going to keep looping until we hit a character that our proc doesn't succeed on. And then we're going to set our count based on where we currently are, which is going to be ahead in the buffer, minus the address of where we started, right? And that is going to tell us the difference, right? Because we're using it, right? If you diff two addresses, that tells you the size of the thing at that address, especially with byte arrays. Also, I have to feed my dog. Give me 1 sec. Can I not pause? Oh my gosh, I'll be back. All right, the dog has been fed. The puppy has been fed. So now we can keep going. So yeah, all I was saying is if you have a pointer ahead and a pointer behind, you diff the two of them. You just subtract, and then that will tell you the size, right? The count of bytes we've moved forward. So we can take advantage of that, rather than the alternative, which would be, capture.count. Count plus equals 1. Right. For every iteration. We can just do all the work at the end. That is why it's nice to have pointers. That you can, of course, convert into integers and then subtract them. So yeah, now we got a little capture while. And what do we need to do now? So we can do an ident, which is going to be, we'll say if C, or A, and this one, we'll copy it still again. Why not? C less than equal to our Z, or the uppercase thing right here, or I guess it could be anything. Wait, no. We only care about these kind of identifiers, so it'd be true, false, null. So we know these are not going to start with a number. Right, so we can just say if it is it lowercase, is uppercase. I guess this is also a consideration here. With this system, we would also support this, right? Uppercase true, or boz is uppercase null. I don't think I want that, but I'm not certain. So for now, we won't support it. And we'll just do this. Because now, right, if we get to this point, we have an invalid thing. And we can just do a little p.error is tprint basic. Basic.tprint. And this will say something. We'll say line blank. Yeah, error line blank. Expected number. True, false, null. Found blank. So we need p.line, and then we also need the stringified character that we currently have, and the easiest way to do that is we just do one of these. One of u8 stir.data is a pointer to c. Stir.count is 1. We can actually just make that a slice, so we can very easily cast it to a string, and there we go. That is perfectly fine, and then we'll return just right here. Right, this is how we're just going to do errors. It's stupid, but it'll work. So now we can do a nice little, we'll just say keyword. I like keyword. Capture while. P. And this will be the exact same thing. So we'll say C or K is that. And we need another little basic.assert keyword.count 0, like so. And one thing I tend to do whenever I'm writing parsers is while I'm getting the main structure of them set up, I'll just do this, right? So I'll say like number, like so, and then I can see the output directly, just so it's a lot easier, rather than having to, make the structure right now and then go and print that, like pretty print it in a way that works. I can just say number, keyword, object, all that stuff. So that's what I like doing. It's a me thing, I'm a bit quirky, I would say. Cool. So now we got numbers, capturing true, false, null, capturing. Now, string capturing is a bitch, so we're not going to worry about that right now because we need to handle escape characters, so we can't use capture while. I guess we actually can, but yeah, we'll do an object because I kind of want to start seeing this happen. So what we need to do is we need to have a little while, not at end, and so we're not at the end, and C is not equal to a closing brace. And I usually don't like to do it like this. I'll do it in here, and I'll say if C is char closing brace, we can break, right? We can do it like this because we're about to recurse into parse value. And so we will never get, we'll never hit a, what's what I'm looking for? We'll never hit an object. We'll never hit an ending that we shouldn't hit. Sorry. That's what I was trying to say. So, if we see C like this, we need to do a nice little C equals p.data, p.offset like that, right? Because that's going to be, we're going to be at the start, and then we can just go one forward like so. If we wanted to add some error handling, we could say like, if at end right now, return this error, right? Set an error, just say like unclosed object, but we'll care about that later. So we'll do one of these. And now we first need a string, and this is one of the upsides of capture while. But we actually need a couple more things in place, and we probably want to split this out into number. Like we want this to be like literal or whatever. But we'll see where we get just doing this. Yeah, I guess we don't have an expect, which is a bit annoying right now, but we'll get that in a sec. So what we actually need to do, actually, we will add an expect. Sorry, I'm waffling really hard. So we'll say, if not expect, C, or actually just P char, boom, because we're going to expect a string. Actually, I don't think we want to do this yet. Yeah, we don't exactly want to do this part yet. The expect, because that's gonna make it a bit of a pain. So what we'll actually do is this will be a fun way to do this. So we'll do the key is parse value of P if key dot kind is not equal to string. Can I do that in Java? Cool. Okay. And I think I'm about to run forever, so I'm just gonna give myself an error. Now we'll do p.error is basic line blank. Actually, we'll just do a little set error function because I don't want to have to keep typing basic tprintf all over the place, and we'll just say p expected key for objects. Sure. All right. Set error of p parser, and this will just do a little p.error. Basically the exact thing we just did right here. So, and there we are. And we just need a message, which is a string, and then format or args any. So that way we can still do all the stuff we want to do. And this is just going to be a string now. And we just need another little basic tprintf. Is it just tprint? Yes. I always forget. Message and ..args. And there we go. So we can do a little set error. Oops. I kind of didn't want to delete all of that. So we're going to do a little pro tip. Copy. Boom. Hit Control-Z a bunch. Go back in Control-V. Copy this string. Set error. One of these. And doot. And there we go. And that's what we want. Let's make sure. Yep, that looks like a thing. Looks like code. So expected key for object. So now we got a key. Now we need to skip white space again. And we could, in theory, just do a little defer skip white space after the parse value, which would be actually a little nice because we don't have to think about it. Yeah, I kind of like how ugly this looks. So I'm going to do one of these, which we'll start by skipping white space and then check if we're at the end, like so. And then once we're not at the end, we're going to make sure we're deferring a skip white space. So that way, after we finish parsing a thing, we're just going to automatically skip. So that way, in this parsing code, right, we're already going to skip white space to get this key. But let's just make our lives a little easier and ensure that the thing we're at after this is not white space, right? And an easy way to do that is if we had like an expect keyword, we could make it, go and skip white space for us and then return a Boolean that's like, are you at the end yet? We're going to do this, free range, handwritten, the good stuff. So now we just need to check. I guess we still need to check at end. That's a bit tragic. So yeah, we're at the key stage. Then we need one of these, and then we need a value, which would be a parse value, like so, right? And then all we need to do is one of these. So we'll say object is a JSON value. Object.kind is an object. Then, very easily, basic.array add say value value object dot keys is key dot s, and then basic dot array add value object dot values key value. There we go. Little annoyance, but these dynamic arrays need to have the context allocator, which they will, but we want it to map to this allocator directly. So we need to keep in mind that thing. So we're going to do allocator, because I don't want to do that right now. Okay, so we're going to say, well, if at end, p set error, missing value for object, missing value after key, like that, return a boom. If so, C, we don't really need C anymore, so we can do if p.data, p.offset, not equal to boom, p.offset down here, set error, missing colon after key, missing, I guess these would be the same error message. We'll just say missing value after key and then missing that. Yeah, why not? So now what we want to do is we want to say if we actually don't. Oh, actually, this is fine. Never mind. Ignore what I'm saying. So now we can just do a little one of these. If we're going to check an error state. So if p.error.count not equal to 0, return. Because we're basically saying, hey, if we tried to parse a value and there was no value, then we want to return. Otherwise, we want to append these keys. And then there's only one step left after this, which is just making sure to check for a comma. Right, that's all we really care about. Before I forget, let's return a value down here. So there's two kind of ways you can do commas when you're writing a parser. You can do it at the top where you just check if you see a comma and then kind of go about your business from there. Yeah, but in this case, we kind of have to do it down here. So we'll do it before. Yeah, we'll do it before. And remember, this is an optional comma at the end. So, yeah. How does that look again? I just need to make sure I can visualize this. So we find a key, then we find a colon, and then we get the opening brace. We're going to keep parsing until we see a close brace. Yeah, and now we're parsing individual key values once we're in here. So we're going to say key value, and then we want a comma. I guess the way we could do this is, because the way you kind of go about this, if you make it full optional, then you'll allow shit like this, right? Because now you're saying, hey, boom, 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 right? You'll say, hey, like, I didn't see a comma. So the way we can do that is we can just say, after first is false, right? And then we go down here and we say, if not after first, actually, we can do this even easier. If value.object.keys.count not equal to 0 after first equals true, right? Yeah. Then now we can say if after first, boom, then we want an optional one, right? So optional comma, required comma. Right, and these are going to follow the exact same pattern. So we can do if at end p. Actually, are they? So if we're after the first value, the comma's optional. So who can? Yeah, no, we still need to check at end because we need to hit this character. We also need to do one of these. This will be skip boom and skip boom. Right, always good to document stuff like that. That is, when you're manually incrementing the offset, it can kind of get a little weird. And then whenever we come in and do like an if expect, p like that, which we'll actually do right now. What? Set error too many arguments. Excuse me? What? Oh, of course. Message string args ... Duh. Yeah, so I'll actually do this. So expect, you write this in parsers a lot. It is one of these functions. And all that'll do is it'll look at the current character. It basically just boils down to this, minus the error reporting, and it returns a bool instead. Right, so all we need to do is go into here, say if expect. Expect is our parser, and it takes a character, and it returns a bool. If you're writing like a programming language, usually your expect does a couple more things, right? It might take like a token kind, maybe like a bunch of them, and then you just loop through them. So that way you can say like, hey, I want to see an identifier, a number, or whatever, and it's a lot simpler. But we're only dealing with characters, so who actually cares? So we need, hey, if the current offset is not C, sorry, whoop, can't say that on YouTube, not C, not the other thing. Right? Okay, that's so dumb. We expect it, right? So we're saying, hey, if the thing at the current offset is not the character, we return false, and we don't want to increment, right? It doesn't really matter, but we just won't increment. Otherwise, we want to skip it and then return true. So now what we could do is we very easily now have one of these, and we just want to chuck that in there as well. So now we've actually condensed 2 error cases into 1, which is not the worst thing ever. It's not like great. If at end or that, right, then we just return false. And I used to actually, this is actually kind of funny that I'm thinking about it. I kind of changed my programming style around this sort of code where I used to be very, what is it? My default return, or sorry, the ifs I would do to guard against the return would be the inverse, so the case I want to see, and then we'd fail in everything else. So that way the logic for, success or failure, they're kind of in 2 distinct places. So like I would, back in the day, I used to wow, I cannot speak right now. Back in the day, I might have done this. So if not at end and p.data p.offset equals C, return true, p.offset plus equals 1, right? This would return false, right? So that way, if I make a mistake in my logic here, I always fall to the false case, right? I always fall to the failure case if this logic is slightly off. And when you're writing bigger functions, that's a nice thing to have, where you're just saying, oh, I'm going to guard against, the truthful statements and then return trues once I see enough of those, and then everything else will be false. The only problem is it's kind of nice to know that when you hit the bottom of a function, that is the good, solid case, like that is the correct case. And you're guarding against the failures that you can think of. Right? You can see even when in me saying where you can think of, that's a bit weird. Yeah, I don't know. I feel like I can read the code a little better when it's a bigger function written in the other style of handling failures first and then the base case is correct. But it doesn't make sense in my head to do that, right? Because it seems like, well, you're going to, obviously, you're a human being, you're going to miss cases. So we'll do that for this, right? So we're saying, hey, if we're not at the end and the character is C, then increment the offset and return true. If I messed up at all in here, return false, right? If one of these things is wrong, I don't know. Yeah, it's a weird programming style thing that I've sort of tried to figure out a little more recently, or like I've trying to figure out my opinion on it. Anyways, so what we need to do is we need to say if not expect p char of semicolon, and we are after first, right? Because if we don't see this and we're after the first one, wait, let me think that through. So if we don't see a comma, and we are after the first. Okay, this is kind of the same style, right? Then we're okay, right? Right. Optional comma. Otherwise, if we get to this point, then we've seen a comma. We've expected the comma, but we're not after the first one, which means it was required, right? I'm talking too much to where my thinking's getting rough. So let's just do this. We'll do if not expect this. And then we'll go down here and we'll say, hey, if we are after the first, or I need to rename that. That's a horrible variable name. We need to say optional, comma, allowed. There we go. So if we don't see one of those and it's an optional comma, right? Sorry, my brain, it's just this optional, like I said earlier, I was like, optional commas are easy. Now I'm struggling to think about it, but it's more because I'm talking and like making it, I'm making content. I'm not in my peak programming state right now. So yeah, an optional comma, we want to only allow it if we have seen a value before and we're at the end. Right? Because because it's actually more permissive this way than normal JSON, where you kind of have to know you're at the end. You have to like peek ahead one. This is just, we don't have to peek ahead one. We can just say, hey, if we see a comma, cool. Yeah. Fuck it. Let's just allow optional comma all the time. I don't really care. We will fix it later. So we'll just say, hey, actually, yes, I like that a lot more. Let's always force a comma. We're gonna enforce that you end it with a comma no matter what. So we'll say that. Then we'll say set error. Expected comma after value. Return. Boom. Like so. So now we always need one of those bad boys. Okay. So it's basic.print out our object. Basic.print value. Yeah, cool. So there's that. This is going to be basically the same thing, except we're just going to parse values in here. All right, so we're just going to do one of these. And we can actually reuse our expect. Even though, we'll just do the offset. I like that a little more. I'd rather not have to do all that other nonsense. Just to skip something we already know is there. So we'll do one of these. And we don't actually need to increment our offset, because remember, this is going to do it. This is going to do it. This is going to do it. Like, everything is going to be incrementing our, what is it? Everything's going to be incrementing our offset. We can get rid of that really quick. And then all we need to do here is do a nice little value. We're just going to copy one of these. Oops. And value is array. Boom. Value, or V, is parse value p if p.error.count not equal to 0. Set error of p. Expected value within array. Now there's one thing. Actually, no, there's not. Ignore me. And we actually want to do this here. p.error.count not equal to 0, or the key kind is not string. Because we're going to get an error in this parse value. Right, and you'll see why a lot of people would opt for this setup, so I can just do that. And we might actually go back to that, just because it's a little easier, but for now, I like single return value. It's a little more permissive, and if we want to ignore errors, we can ignore errors and just get like fragments of the file written, so I don't really care. Right, I never said this was going to be like a production level amazing JSON parser. I want to make that clear. Cool. And we actually need the same comma. What the heck? And we'll make sure copy this and say after value in object. Same thing here. Value in array. Cool. Yeah, same thing here. Return value. And we need a little semicolon. And we're not getting any annoying, like infinite loops, which means we're actually terminating correctly in a lot of cases. But now we just got to do string. So we got to do stir p.offset plus equals to 1. Stir is capture while n. And we will just say, right, and this is where I was saying that we might not be able to use capture while, because when you have a string, you could have character escapes in the string. Right, and you just want to skip past them. Especially when you're escaping strings within strings. So that's a bit annoying, but we'll just do this really quick. So we'll say while s not equal to char boom, like so. Basic.assert stir.count is not equal to 0. P.offset plus equals to 1. Return kind is string. S is stir. And we are actually infinitely recursing. So let's see what's going on. Actually, I think we are. We just might not be printing. Print C. A little basic.print C. Oh, nice. Okay, so we did actually exit. Can I do this? What are we actually running again? So JSON unmarshal of that string. I should probably do this first and foremost, and then go to JSON unmarshal and make sure we're not infinitely recursing again. Oh, wait. Okay, no, never mind, we're good. So we go into parse value, we skip the white space, and let's make sure we're actually calling this basic print pre-skip white space. I don't have a debugger set up fully right now on this. I know C-line is a thing on Mac, so I'll probably end up using that. I just haven't installed it. So we are doing something, at least. Let's just do this. Objects. Basic. You can tell that I never namespace basic. Okay, so let's kind of pretend to step through this. So we go into parse value. So what would I expect the call stack to look like? So that we go into parse value, which is then going to parse. It's going to skip a bunch of white space. Go into parse object. Object is going to go key value, key value, key value. Where value is an object, it's going to see this. Comma. We're going to recurse all the way back up to the top one. That's going to see this. And then we are going to end the loop. Yes, that is what I would expect to see. Is it because I am not looping forever? So I'm only parsing one time, which should be fine. Let's see. So let's just go a little basic.print of our key. Okay, so we got a key.s. Okay, we got that key. Let's see, k.value. Okay, we got that too. Okay, so we're in foo bar. And we see that comma, so that's correct. Do we see it after this? We do. Oh, let's make sure these are returning something for now. So kind is number, where s is number, because we haven't added string parsing in yet. Same thing here. So we'll do, now we need to do if keyword is this. true, false, null. And then we're just going to return off of that. Kind equals bool. Actually, this should just be true, but we can't do that. So bool, b is true. Sometimes it's actually nicer to have a runtime value so you can use it rather than having to, check if it's true and then whatever. And this will be a none type because it is null. Otherwise, we get down here. Now we got another error case. And we don't need this anymore. Keyword expected true, false, null, but found blank. Cool. Let's just make sure we're printing errors. That's probably a helpful thing to do in this case. So let's do a little basic dot print error. A little p dot error. No error. Okay. Cool. Peculiar. Peanut offsets. And of course, that debugger, I'm basically having to do this. So I'll just say array. Right, is an array as a value. I should probably actually name these the thing they are. I don't know why I just chose value. Array. Array. Oh, I guess that's why array.array. Array.array. It's probably gonna be something really stupid, like my capture while is not doing what I expect. Object. 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 Oh, we were shadowing at the top. Oh, that's totally what that was. Yeah, we were shadowing. We get a crash. Interesting. In parse value 95. Value? Oh, okay, yeah, it's because I was shadowing the stupid. It was just me naming it. Me naming it dumb meant I shadowed the variable, which is cool. Let's just make sure we have a stir, like so. Yep, and now we see all of our strings, which is correct. So we see foo, bar, baz, boz. X, Y, Z is vector 3 with the question mark, parent with the question mark. We see a none, no error. Cool. We can delete all of our basic.prints. We can do one of these. Cool. So we're returning a none type, which is strange. So why are we doing that? So we have a JSON object, which is where we're going to go in first, and we got a key, then we got a value. So we might actually be hitting that error case now. So let's do in here basic.print error. Another error. P.error. Okay, line 9 expected number, true, false, null, but found that. Okay. 4, 5, 6, 7, 8, 9. Oh wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Interesting. Are we just not updating C in the object? No, we are. So we go to p.offset. So we skip. Oh wait, wrong one. C is p.data, p.offset. If C is that, then we break. We skip it. I see. Line 9. Expected key for object. We would be overriding the error here, so I just want to see. Okay, yeah. I see. Expected number, true, false, null. But found that. Expected number. So it's one of these two places. Oh, that would probably do it. Oh, no. Okay, never mind. Sorry, I thought I was doing a dumb. Okay, so we're hitting this case. So we're saying, hey, we have a number. Hmm. Not hitting an assert there. False null is greater than A and less than Z. Greater than A, less than Z. Got assert in that. Are we going one too many? We might be. Let's just make this error a little easier to clean up. So we'll say if p.error.count not equal to 0. Number true or false. So we didn't see a string. All right, let's do a simpler object just to make sure. String and we'll just do one of these. Okay, no error, and it returned an object. Let's add a key. Bar. Who is bar? That's the error I would expect. Right? 'Cause we're saying, hey, we expected that. So now we should expect this. So it might be in our object parsing. So we're going, hey, if we didn't expect that, so if we so expect, maybe this I should have written in the other way. So we're saying, let's see, if at end or p.data p.offset equal to c. I just want to rewrite it for my own mental. P.offset plus equals to 1. Now, this is a lot easier for me to follow in this case. Where are we failing? Line 2. Expected number. False null. Okay, so we go for a key. We return there. If we don't expect a colon, we set an error, and we should probably return. Parse a value. Okay. I see. Let's do one of these really quick. Print object. ToString. We're gonna write a little quick utility macro. Macro. And we want one here, toString. C is a U8, and this is going to return a string, and then we're just going to expand that. Stir is a U8. Data is at C. Actually, let's do this the correct way. We don't need to make it a macro just to take advantage that we're returning a pointer from a local scope. Count 1, return stir. There we go. There. Oh. That'll do it. Cool. So now we can do that. It's not printf, of course. toString. It needs to be a pointer. And we are getting nothing. Interesting. We're getting a new line. I see. I see. Interesting. Okay. So what's actually happening here? So in our string, we're just going to parse two strings. So we're parsing an object and two strings. I see. So that is not correct. That's pretty strange looking. Just a whole bunch of junk. Okay. That seems very strange. That we're just seeing a bunch of junk. Data period offsets. Just delete that just to make sure. Okay, that's not it, of course. So we're skipping white space. Right, which would mean that we're actually gonna, so we're finding a new line. So at line 0, right, this is why we skip white space, so we can do this. Right, so if I go in one of these, to string pointer to C, right, we're just gonna see a space character. I feel like this always happens when I write a parser. What is happening there? Let's just go to this macro and make it let's make this an actual macro really quick. Oops, that is the wrong location. I call myself the Jai guy. Get data equals C. Yeah, what is going on here? So we expect that. Okay, true, false, null. Expected number, true, false, null, but found random shit. Expected key for object. We just make sure it's not ruining my own day really quick. Not. Okay, so we capture while we say, hey, capture true, false, null. Okay, yeah, we would hit one inserts if this was true. Just for my own sanity really quick. Actually, no, I won't. I'll just keep it stupid. Okay, so character, let's do 9 or a dot. Capture while, that's fine. So all we're going to see is an object with a string, right? And of course our error handling is somewhat correct because we're saying, hey, expected boom after value in object. So we see that, wherever that is. So we see this. Oops. We see this, and we add to our keys and our value array. And then we're going to go to the next iteration, which is going to say, hey, are we not at the end? Cool. Check the character at the current offset. Is it this? Break. Skip it. Return. So where did I make a mistake? Not print. Excuse me. Okay. Why is this returning a weird string? It's a macro. We already got it. Can I just do this to test it out? Okay, let's just make this. I don't know why that's happening. This usually works. So I'm a bit surprised that it's breaking in this way, especially when giving it the pointer. So we're going to do one of these. Basically the same thing, actually. Except we're going to make it a U8 array. I'm going to do return basic.tprint and Whoa, yikes. This needs to now import basic. Okay, and this is going to that. String. I don't need to do the cast, but okay, so now this is very, very weird. I wonder if we are calling the wrong toString. Oh yeah, we are. Okay, let's import file /macros .ji. Oh, I see. Yeah, so I can't really do that. I could do this. I don't like that. Yeah, so right now I think we're calling what toString are we actually calling into? We namespaced basic. So we're not calling into ours. What? I see. Let's figure that out really quick. What toString we're calling. Runtime support. Oh. Oh, duh. Okay. Well, no shit. This is causing it to print random stuff. Because we're giving it a C pointer, and then it's trying to count from there. No wonder that's doing that. Okay, that's really annoying. Oh, that's so frustrating. Okay, so let's just do our own toString macro in here. Ugh. Okay. No wonder I was getting nonsense while I was printing it out. Ring stir.data is pointing to C, stir.count 1, return stir, and we'll just make it return that. Okay, that's really frustrating. Oh, and we're probably still calling the same one, so let's differentiate ours by making this a macro that does this. I see. We are still doing... Oh. Okay, that's why that will happen. I don't think we need to do a skip white space here. We really... Yeah, we really don't need to do a skip white space at any point in this. These are skip white space busted. While we're not at the end, we want to do... So we're just going to increment our offset. So C is p.data, p.offset. While we're at end, not at end. Checking if our offset is greater than or equal to our count. We got space, we got tabs. E increment offset. As we see a new line, we just increment that. Break. That's correct. Okay, let's see. I mean, we're definitely getting new line characters. That's a bit of an annoyance. So I wonder what's happening. Yes, this is what's happening. Okay, we're just gonna try this really quick. Skip white space after that, and then return not at end. Actually, no. We'll do this. I think that worked now. Yeah. Okay. So the reason why this is breaking. Let's go to our toStrings really quick. That's good. Yeah. So the reason why is because we would parse a value. For some reason, it's not skipping white space after this. Oh, probably because I'm not calling skip white space anymore. We're still going to get this error. Oh, wait, no, we're not. What did I fix? Oh. 1024. That. Yeah. Was this not broken the whole time and I just went down a rabbit hole because it's printing the union? I think I just went down a long rabbit hole for no reason. So let's just say add a 1 hour, 15 minutes to make an edit. Thanks, me. I don't think anything was actually broken. Yeah, nothing was broken. Okay, that's really frustrating. So now let's do object or object.keys. Object.object. We're just gonna do. Let's see. So we could say to string. I like a JSON to string right here, or just to string. Yeah. And I think what we can do is we can do a little string builder. Whoops, that's not it. I want an object. JSON value. That's just gonna return a string. And then we're going to do a nice little string builder. Turn builder to builder. String B basic. Now we just do the classic. If value equals this, and I think we actually need to differentiate between empty and null. So we're going to do empty and null, or none and empty? Yeah, I like empty. That. Just to make sure we're not printing empty value. I guess no, because an empty object would just be. Yeah, we'll just keep none. That's fine. So case none. Return. Or wait, no. End. B. Basic.append. Null. This would be number. So we'll do all of our primitive types first, which I actually want to update. For, I don't know, there's something about having primitive types first that's a little more, it has a different mouth feel, you know? Like you have your bool, then you have your number, then you have your string. It's like as things get more complex, like this, it's like it has a nice vibe to it. This is the kind of vibe coding I do. So, you know, the aesthetics, not the shitty AI version. So bool. That's basic. Append of B if value.b false action. And let's see, we got a number basic.print to builder of B. We're just gonna use default printing like so. String. And finally, we have an array. Array is very simple. Value.array. If it index less than value.array.count. Basic. Comma. Otherwise, we do basic.append string value for it. Yeah, it's going to take an indent level of 0, and you'll see why in a little bit. Like a default indent level right here. So, okay, for value.object, because now we want all the keys first, and we'll just use that, and we'll say value. I don't know, I need to stop doing the thing where I'm just like talking through every single piece of code I'm writing. You know, you guys have good attention spans. Programmers, you know, or soon to be programmers. So I should need to say literally every character I type. So let's see, value. It's builder. These, and then these. And We always have that trailing comma, because why not? This will be the it and the value. To string value. And that is correct. And then we need to say indent is indent plus 1. Oh. Object dot values. Oh. The. Me and my shadowing again. Value dot object dot value. Every subscript must be an integer. Oh, it index. Duh. Cool. So now we should get basic bad printing of our JSON object. So we can say to string objects. Yeah. Okay, well, I forgot to print a couple of things in there. Let's see. So the first one is in the array. You know, we kind of need one of these. We're trying to just print valid JSON. Not invalid JSON. And then we need the same thing for this. And we're actually going to do it now. So we're going to do this. And this needs a comma and a new line. This needs a new line. Yeah. Comma and new line. Cool. So now we got that. And now for the fun part, so we can say if indent not equal to 0 or 0 dot dot indent basic dot append. We'll use a tab character. I don't want to use a tab character because we also don't want to do an indent after the keys when we're printing an object. We just want one. Oh, so we can actually do this in a nicer way. So we want this to stay 0, like so, and then when we do it, we want to do it in this. So we'll say indent or add indents, I guess. Boom, boom, boom. And add indents. Actually, we will make this a full-on macro. So we'll just make it a, yeah, we'll say level is int, and b is sig.ring builder. So do like that. Now we can just, yeah. Cool. So we got that, and now we need to go into here and do add indents b and indent plus 1, which probably should be at the start. Cool. So we're almost there. The only problem is that we're doing this. Like, we need to actually do indent plus 1 here, but that's going to indent the keys. That is because we are doing an indent every single time. And we actually only need to do it in 2 cases. That's 1 here. Right? We only want to do it in arrays. Indent plus 1. And we want to do it in here. Oops. Like that. I think no, because this is going to do it twice. Yeah, we only need to do it there. And here. Yes. Okay. So we need to also re-indent this one as well. So indent. This also needs to be plus 1. Cool. So now we got a little thingy going. Where's, oh yeah. Cool. So now we got, where am I still printing an error? Okay, here we go. Nice. So now we still have, okay, Yeah, I don't like tabs now that I'm thinking about it. I don't have anything against tabs. I just think they're ugly. So we could use 1 space. We could use 2 space, which is sort of the, yeah, so it'd be 1, 2, 3, 4. We'll do 1 and then we'll multiply it. Indent times 2, or indent plus 2. It goes from 0 to 2 to 4 to 6 to 8. Like that. Yep, so 2, and then this would be 4. Yeah. 2. Do we actually need to do that when we're doing an array? Yeah, we can do this. Sorry. I can just pre-do the indent rather than making the value do it, because the value is not even going to indent itself anymore. So we can do that, and then this can be 0. Right, now we can do 2. No. Why am I struggling to think about this right now? Oh no, we need to do it in objects. Yeah, okay, we actually do need to pass it down because the objects won't be able to indent themselves. Of course. Yes, this looks correct. Boom, boom. All right, so now we got a JSON parser that can print out JSON. So the real trick, make sure that this works correctly, is we get a before JSON unmarshal or JSON, right? We print out the before, and then we do after, which is JSON unmarshal before. We print out the after, like that, right? So we could say before, after, and if our JSON parser is working correctly, mention any of the possible overloads. Huh. What is the return type of this? JSON. Oh, because it's giving us an object, right? Because we need to do this to string before, like that. And after is returning a null because it is already a string. What am I doing right now? Why is that returning null? I think that means we have an error somewhere. So let's take that. Print error. P.error. There is no error. Am I just being dumb? So JSON unmarshal goes from a string to a value. And then we want our after to go from a value back into a string, back into the system, back out of a string. ToString does return a string. We did print it. So what is happening with us right now? So let's make sure that this is doing the right thing. Doing the right thing. Yep. Got passed in there. So something's going on here. So we need to do a before okay, and let's just do a little basic not assert okay, and then we'll do the same thing down here. Oh, I see. We are actually failing. Oh, equals 0. That'll do it. Okay. Well, that'll at least that'll at least tell us why that assertion was failing. So then now our second one is failing. So why is that? because it is the same. Oh, it's because how we're printing strings. That will do it. Where is string? So print to builder. One of these. Do like this. And that will cause that to fail still. But let's see. Oh, because we're also printing the keys wrong for our objects. There we go. Yeah, it was just a printing error. We were just printing things slightly incorrectly. And that was causing the error to bubble up all the way. And now, yeah. Now we have our before, some object, foo bar baz 0, foo bar baz pause, z is vector 3. Cool. So you might be noticing all of our numbers are 0, of course. That is to be expected because we have just kind of ignored that part. So now, need a little basic dot parse float. Is that in basic? No, it's in string. Strings. String. And string dot parse float, and that's going to return us the float and an OK. Strings. And what does that take? So that takes delimiters, string, spaces. Okay. Yeah, we can just kind of not care about this right now. So we can do a number. I think it takes a pointer. Yeah. I don't know why, but it does. If not okay, set error. Malformed number. We need a. I don't know if it modifies the string. Like, I don't know if it modifies the number, so I'll add a character that I know is definitely not a number character. Like a modulo in this. This. I see, it still works. Okay, so parse float is a little weird. Yeah. Well, we can ignore that for now. At to do. This is a bit weird. Parse flow works a bit weird. Okay, so we can do n equals f. Now we got our numbers back. Look at that. Cool. What else do we need to do? I think I said to do allocator, so array.allocator equals p.allocator. Oh, p.array.array.allocator. Yeah. That, okay. So we can that to do. Do I have any other to-dos? Logging, allocator, parse. Okay. Object dot keys allocator equals p.allocator. We need one for values. And there we go. Perfect. So now we have a JSON parser that can parse itself. Of course, it's not perfect. There's probably some bugs hidden in here all over the place. But we got most of the way there. Let's see. So there's a few things we can do for fun. So JSON marshalling is a little less fun because that's going to just be going through type info and then, yeah, writing a little like marshaller to dump out. Basically, it's going to look a lot like this, except it needs to handle like structs and whatnot. So it's a little more boring and like pointers and stuff like that. JSON unmarshal for this will be a little more fun because we're going to get an object type, like a JSON value, and then we're going to convert it into a J type, and that is going to mean it's going to be a little fun. But I think I'll save that for now. I at least have a little JSON parser that I can use for a lot of stuff, right? So we went from a little JSON string. Actually, does that? I think, yeah, that works by proxy. That's really funny. Yeah, so it's not the most, robust parser, but hey, if your whole job is to get some JSON in and you just want to describe your data, honestly, it being a little more forgiving about values like this, well, maybe not this one, it being a little more forgiving is not a bad thing, because JSON is already a pretty loose data format, so you don't really need to care. Yeah, and so let me just make sure. I missed that. Boom, assertion failed. I missed that. Assertion failed. I do true right here, like a weird object. Boom, assertion failed. Why is this failing, though? And that don't sound right. It's because why? Okay, so empty objects fail for some reason. Interesting. Okay, that's a bit weird. Let's do a quick array, though. Values. 1, 2, 3, 4, 3, 4, 5. And because we need a trailing comma everywhere, we need this. Which we could make a little better. So does this break too? I would assume yes. Okay, it does. But it breaks on the after, which is weird. So it breaks when we reparse. A bit weird. Let's just try to fix that array, the empty array first. So, see this, we get to an array. We skip that, of course, and then we go into here and we say, hey, if it's that, cool. Skip that. Return the array. Array? Ugh. Okay, so it did return an empty array. Is this the stupid printing code again? I don't think so. I just want to see. I usually like doing it like this sometimes. So I just kind of want to see if that's... Ooh, that fails for a different reason. Okay. Probably because I did something stupid. And we're not dealing with comments, which is a nice thing to do, which I should have done. Usually comments are a really nice way to make this a lot more testable, because you can just comment out broken cases or cases that work and simplify it. It's not hard to add them. You literally just say, hey, before we start checking stuff, do we see double slash? Ignore up into a new line. Like, you can use capture while until the end of a new line and then keep moving forward. Okay, so empty objects and empty arrays break things, but they don't if I just do this. Right, so if I do that, oh, it still does. Okay, I see. So let's do broken one is this. And just parse correctly the first time, but it doesn't the second time, which makes me think this printing code is very wrong. I wonder, is it? If we can say if value.object.keys.count not equal is equal to 0, basic.append b like that. We do this, like just make it an empty, and then otherwise we do all this stuff. I just want to see if that does it. Okay, so it is something, it has something to do with how we're printing the value when it's empty. Okay. I'm just messing around to see if this is what's causing it. It might be like a white space thing, actually. Yeah, I think it is. I think it's got to be. I bet you if I add a skip white space to here, it would be fine. Yeah. That's kind of annoying. That's actually really annoying. Because that means that our skip white space that we're doing somewhere in here is not doing the thing properly. So let's go back and print the error. Print error. And we got no error. Okay. So we are just failing for no reason. Okay, I see. Yeah, that's a bit frustrating. You know, honestly, we only really need to skip white space in a couple places, so maybe we do it like here. Like at the end of the... What? Skip, oh, skip white space. Right, so there's that one. It doesn't do it, though. I see. Yeah, I don't really want to chuck a bunch of skip white spaces everywhere, but maybe that is the move for this. It's very annoying, but it's not the worst thing in the world, right? Like doing it right before we loop. And then we're not deferring and doing it every single time. Right, but that also wouldn't make a difference if I do this. Right, then we just do that. And it still works fine. Okay, so that at least fixes that. Broken 2 is an empty array. That works fine. 1, 2, 3, 4. Yeah. So one way we could handle this, allowing it, like the last value, is if we expect this. So if we go, hey, if we don't English, if we don't expect this, say, hey, if p.data p.offset is this closing character, then we can just break here, and that'll fail for some reason in 327. I don't know why, but if expect that, or expect p, boom, boom. I don't think this will fix that, and we're gonna go one past anyway, which is ugly. Yeah, I mean, I don't hate it that much. It's just if I wasn't recording, I could probably think about that a little better. But we at least have a working JSON parser, even if it is a little fiddly. You know, it still does the job. We can start using JSON. I could probably, actually, isn't there like a JSON testing thing in JSON testing? JSON parser test. I don't know what this website is. Well, okay, here we go. Let's go test parser. I don't want huge JSON. I just want, can you give me like a fun, easy one? Oh, actually, that's kind of nice. We can test if, let's just see if it does this. Okay. JSON unmarshal. JSON unmarshal. Just an array of 1, 2, 3, 4. and this should work. And it does. Yeah, we can just print an array, which is nice. So we can just handle chunks of JSON. Same thing if I probably just do like 3.14, that'll parse the number. If I do true, that'll parse that. False, null, and finally an empty array, or an empty list. Object, what am I saying? Oh, so that's a quick little bug. That means that our array printing is wrong. Where is that array? Why are you broken, actually? Indent. It's 4? I don't know. Pretty printing is always annoying. And so it's just broken right now. So I can fix that later. I don't really care that much. I guess the other thing would be like minifying the JSON, like just turning it into a big glob. And that should be like pretty simple. We could even do that when we're parsing or when we're printing, just have a flag that says, do the thing. But I think I'm going to leave it for now. We got it most of the way there, enough to like check it in at least. I'm pretty happy with that. And these all needs to be scope filed, which it is. This, and let's see. What are we checking in macros? Nothing. Cool. Okay. Oh, right, because this needed basic now. So let's go and run through the tests just to make sure I didn't break anything. Cool. And that all still works. Perfect. Cool. I think that's good for now. Coding/JSON. Start. And we push directly to master here. Perfect. All right. Thank you all for watching. I hope you enjoyed the chill me talking for like an hour and a half, maybe 2 hours. But yeah, hope you're all having a good day, good night, whatever time it is, and I will see you all later.